Okay, so yeah, let's begin. So first 10 minutes I'll take talking about what exactly Groovy is, how it fits around the programming ecosystem, and the Groovy story. What is Groovy? How we'll run our Groovy code. I am assuming that you guys have installed Groovy on your system because this will be more uh, hands-on rather than theoretical. So we will be writing code, a lot of them. So you should have Groovy installed by now, and then we'll discuss with objects, uh, Groovy story, and these are all nonsense. So okay. So after that, we'll talk about data types and we'll talk about various data types that Groovy supports. And after that, we have collections. We'll talk about collections in Groovy, how we can use ranges, lists, maps, and sets. They are very important when working with multiple data. Then we'll talk about closures. And by the way, this I will just, it won't be in this particular sequence as I've shown on the slides, because much of the concept that you learn later may be used earlier, and I'll try to explain that as well while we go through. So something like control structure we'll use earlier also when we go through simple data types, but just for completeness, I've shown it here. Okay, and then we'll do file handling and working with dates in Groovy, and then we'll do some OOPS concept. We'll do a generic discussion on OOPS, like what are classes, object, constructors, and all these things. And then we'll see the Groovy approach to object-oriented programming. And last is the business rules that we'll discuss. Okay, so yeah, let's just start with. Okay. If you guys can start your console, like you can just type in, if you have installed Groovy, just type in Groovy console on command line, and this should open something like this. Uh, just give it a second, it will take some time. Okay. All right. So first thing, we'll talk about Groovy in a nutshell. So actually, Groovy was created by James Strachan, and the concept was basically he's actually a Java developer, by the way. So he and his partner spouse were waiting at an airport, and the flight was delayed, and this guy Jim Strachan, he went to a cyber cafe, internet cafe we used to have earlier, and he started going through Python uh, because his flight was delayed. So he started learning Python, and he thought like a lot of Python made things very easy for as a programmer, and he thought that even to do simple operation in Java, it takes a lot of lines of code. So that is where the idea was created for Groovy, to make it more uh, beginner friendly, to make it more dynamic in nature. Okay, so that is how it came into existence. And uh, so yeah.
Sir, how did you get this particular console, Ruby console?
Okay, I just wrote this thing, Groovy console on command line. If you haven't,
Okay, okay.
just write Groovy console and this will pop up. Okay, and I'll say something currently while we are discussing high level overview about Groovy. If it doesn't make sense, I will just come back to it later on. Like this is just the start. So Groovy basically is optionally typed. It is majorly used for scripting language. Okay, but don't get just it is not restricted to just scripting language. So if you think of it, Groovy is used in building web application. It is used in there is a something called as Gradle. I'm sure some of you have worked on that. That is a build automation tool. And Groovy is also used to automate pipelines on Jenkins. And then there's this Groovy on Grails, which is a web framework. And then there's something called as Griffon actually, which is actually used to create desktop application. And by the way, Groovy is open source. So if you go to something like, you can go to its This is the official Groovy URL, groovylang.org, and you can fork on GitHub also, by the way. So this is open source. All of the code on how Groovy is made, it is actually here. You can see Groovy is written majorly in Java and Groovy itself, and they have a very beautiful documentation. You can go through it, how you can install this. All these things are there. Okay, so if you are confused about anything, I would say just go and read the documentation. That will help a lot. Okay. Okay. So we'll start with coding right away. Okay. So first thing first, let's actually start with a simple print statement. Okay, like how we do it for. So we can do it in two ways. Print hello world, and if you press Control R, it should actually print something like this: print hello world. Okay. So it is very simple. Just use the print statement. But you can also do print ln, which is actually print line. Okay, and this is what we mostly use. So what it does is it prints this hello world on your command output, and then it adds a line to it. So okay, so I'll show you what that means in a moment. Print ln another output. Okay. uh, So this actually hello world, and then it actually added a line, and on the next line it printed another output. If you just take this out, okay, and then run this, the line will not be there. So if you want to add a line to it, you have to use something. Println is the sorry. Okay, println is what you have to use. Println stands for print line. Okay. Another thing that we have to discuss here is the use of assertion. Before that, let's actually do one thing. How do we write comment in this? So a single line comment is usually written in this way. It is just taken from Java world. So double forward slash will actually give you a comment. Okay, this is a single line comment, by the way. So I'll just make a single line comment. And if you want to have something like multi-line comment, that will start with this thing. Sorry, this, and you have to end it with that. So anything in between. So if I write anything, this is random random stuff, and this will not be picked up by the compiler as it is a comment. Okay, so there are two ways. Even there are more ways than just two ways. There's this thing called as Java doc comments. Okay, documentation comment, where you use something like double asterisk, and then to end this you use this thing, and this is actually used for documentation purpose. So when you're creating a method or anything, you can use this, and the documentation tool will pick it up for you if you do it this way. Okay, so okay. uh Okay. Next is the use of cert keyword. We'll talk about data types and everything in a moment. This is just like starting. So now just hang in there. We'll use the this statement a lot, assert. Okay, and what it does, it basically tells you it's like a unit testing in your code. Okay, so when I say assert one is equal to one, and if I run this piece of code, no, it won't do anything. Like it won't give me any output here. Okay, uh but if the condition that I put in the shirt keyword here, if that is wrong, it will flash me some error. So if I say something like if one is equal to two, well, in that case it will fail, and it will tell you very clearly that you are comparing one with two, so that is a false assertion. Okay, so this assertion is actually used at a lot of places in Groovy. Okay, so I can show you a quick example with assert. So text into 3, and then okay. Yeah. So what this piece of code is doing here, we are basically doing text into three. Okay. So this is actually anything that is text is actually a string in Groovy. And what we are doing here is we are basically multiplying it 3 times. So this will actually, when you multiply it with 3, it will essentially become text, text, text. And then I'm adding this left shift operator. Okay, this is sort of append. Okay, so what it eventually will become is something like this: text and hello. And then I'm saying fetch me the size of this whole thing. Okay, so this is text, text, text 12, and then hello, which is 5, 12, 5, 17. And if the size is same, equal to 17, then give me this uh, just pass this assertion. Okay, if you make it something else, then it will fail. So if you run this, it's okay. It is saying that, yeah, this side of the assertion is equal to this side, so I will not give you any error. If you did something wrong here, then it will blow up. It is saying that, no, this side is actually equal to 17, as you can see from here. This side is actually equal to 17, and you have 18 here. So this is useful when you're doing inline unit testing. And
So Saurav, is this like it's basically like evaluating a condition, like if I'm understanding it correct? So is it like a alternate for the if statement, or is it like just to like it just evaluates and that's it, or does it like execute for the statements beyond this?
No, it doesn't execute anything beyond this. It is just like a unit testing in place. Okay. So
Okay.
if statement has more things to offer, but assert will basically be it is more useful if you think in terms of if you're calling some method. Okay, let's say I'm calling some method over internet. Okay, API call.
Okay.
And I have these they usually you get a response from an API. So maybe the status code of API is 200 to 299, let's say, for example, somewhere between in that range. I am saying, yeah, my API call was successful. Okay, so I can create an assert statement with that API call and say, if it is equal to this, just pass the assertion. In case if that call fails, and the status code is not between 200 to 300, right? Not including 300, by the way. Then
Right.
it will not work. Your program, whatever so if for this statement, okay, I will write code in better way using some text editor. I'm just showing it for now. So if I have something println beyond this point, okay, I'll say my API call was successful, right? This will, if the API call is not successful, this will not run. Okay, this thing below this one. Okay, as you can see, the assertion has failed. Assertion has failed, so it will not go beyond this point. Okay, so this is more like an inline unit testing.
Okay, got
Yeah. Okay, and some of the things that we'll mention here is that the semicolons are optional in Groovy. Much of the things are actually brought from Java language. It is actually used for Java developers only to complement a lot of things, but you can use it on your own without the need for Java. So they have actually improvised some of the things. So if you see, I can write int x equal to 10, and we'll go in data types in a moment. So here, what we are doing is essentially saying, just give me 1 second. I'll comment this part. Okay. So this is actually printing me 10. Okay. The semicolons are actually optional in Groovy. Okay. So as soon as you hit line enter at the end of the line, it gets on its own that this line has completed. There is no need for semicolon. If you want to intensely put it, you can go ahead and put that, but that is not at all required. So 11, and you can put semicolon. Okay, and then println y, and this will work as well. Okay, so semicolon is not needed, just hit enter and that's it. Okay, one more thing I want to discuss before we actually start with data types is that everything in Groovy is an object. Okay, and everything, by everything I mean everything. So if you do int x equals 10, okay, this 10 is not just 10, in a sense that it is not just the primitive 10 that we have been used to. It is actually an object, and on this 10 we can actually call methods. Okay, so we'll discuss object oriented also later on and what it means to actually do that, but for the sake of completeness, I'll just put it here. So println 10 plus 10. Let me get this. Okay, so this is 20. Okay, behind the scene it is not just 10 plus 10 that is happening. Behind the scene it is something like this that is going on. Okay, print 10 dot plus 10. Okay, so think of everything in Groovy in terms of object. Okay, an object, by the way, is nothing but data as well as behavior, and let's discuss that later on. Okay, let's begin with our just a second. Simple data types. Okay. So there are basic data types that we'll discuss first, and then we'll go on to collections and everything. So first thing first, we'll discuss these kind of data types. So integers, booleans. Then we'll also discuss a little bit of double or float, and strings. Okay, so integers are basically your numbers, 1 2 3 4 -1 -2 0, all inclusive. Okay, and there's a range for that, but let's not go into that. So let's define something. Int x equals to minus, let's say -10 or -10. Okay, so this is actually an integer, and you can see how Groovy actually sees it as an object by just doing something like print line x dot get class name. Okay, so if you run this code, you should see something like it is showing it as integer, not this small int that I've used here, rather than this integer. Okay, so this is actually a wrapper. So what I mean by that is, if I have this open here, okay, so when you do this something like okay, it's not working. One second. Now let's go back here. Okay, so this x actually is, and I've told you earlier also to think in terms of object. It is not this primitive int. Okay, primitive in the sense it's not just the value itself, it is more than that. Okay, so when you initialize it with int x equal to -10, okay, Groovy automatically made it from this simple value of 10 to object with a value of 10. Okay, so basic int actually got converted into a wrapper integer. Okay, so again, booleans, you can declare that way also. Boolean has just got two value. Boolean y equals, let's say it has true or false value. There are only two values in this. So booleans are actually used a lot in conditional, and we'll see that as we progress. Then there's double. Double is basically decimal numbers. So if you have something like 12.3, that is actually a double. So in Groovy you have to mention it either with d or small case d, or you can just declare the data type in front. So this is what I mean by data type. This, when you declare it this way, Groovy tells this current script that z is actually a double. It's a floating point number, and it has to think in that terms only. Okay, And then
is there a float as well, Saurav, or it's only a double?
There are a lot of things. We'll come to that. The float is also there. I just want to okay, there is float as well. So again, 14.5. Okay. To be honest, there are more than this. All these data types that I've shown. There is something called as, if you don't declare anything. Let's say in Groovy, by the way, yeah, you can either declare the type of variable, or you can say def. Okay, def is used when you don't want to think about the data type at the moment. Okay, you can use this is actually the dynamic nature that comes into play. So def x equals to, if you do something like 14 maybe 15 point something, some random number, what it is essentially does know is x, if you print the type of class that x belongs to, and by the way, you can just select this and run this, it is showing it as big decimal. Okay, so by default in Groovy, if you don't declare it explicitly, like we have done it here and here, okay, if you just let it be def, then it will pick it up as big decimal and not float or double type. Okay, that is the by default. So decimal points by default is big decimal. Okay, there is also something called as big integer, like you can declare that way. So def big integer equals to maybe you can do 1 2 3 4. Okay, and you have to write g that way. G is used for big integer. So if you print line the type of dot get class, it should show you that this is actually a big integer. Big integer. Okay. Then what else? We have strings. String is actually a set of characters that you can use. And by the way, in Groovy, you, even if you use single quote, it will take it as a string. And even if you use double quote, it will take it as a string, and triple quotes also are available. So I'll show you with example. The string str equals so hello. Let me get rid of this. Okay. String str equal to hello. Then string str2 equals hello. And we can also have 3 quotes, and they all have purposes built in, and we'll talk about that here. This is also valid. Okay, so let's just execute this. It will not print anything because we're not printing it. Okay, it will just print the last thing anyway. So there are three three types of strings in Groovy. Actually, they are all type of string class only, but with these two we get added benefit, and I will show you what that means in a moment. So let's say I have something like a variable is there. So def name equals to let's say something like that. Okay. So for this one, if you are using this single quoted one, okay, we'll have to add, okay, println hello, and then you add this, and then you add this. Okay, so if you run this piece of code, this will work fine. Okay, it will print hello Kumar, but you can also pass your variable inside your string. Okay, and what I mean by that, if I pass this variable name to this string, it will error out currently. So if I do this, let me just repeat this line of code here. Okay, so if I print it, by the way, you'll have to use the dollar notation. Okay, dollar notation makes it clear to the compiler that this actually is a variable that we are trying to refer inside of this string. Okay, so let's get rid of that. This will error out because this is a single quotation. So okay, this will not error out. Actually, this actually just printed dollar name, which is not what we want. Okay, We want it to print something like this thing, not this one. It just printed out the way it was. So how can we do that? Well, you can use double quoted string or triple quoted string. So for that, we can write something like print line, hello. And then if you use now, as you can see, this color has changed, and now it is able to recognize that, oh, you're actually referring a variable, and dollar name is not just a string like it got it here. So if you use double quotes or triple quotes, it will actually fetch the content of that particular variable. So if you run this, sorry. Okay. If you run this thing, it will print out, yeah, hello Kumar. Okay. So that is true for this thing, double quotes as well as triple quotes. So why
So
would
Saurav, it doesn't matter whether the Kumar is written with single quotes or double quotes, right? It's just that the print ln statement where we are printing that has to be in double quotes.
yes, yes, yes,
Okay.
true. Yeah. So if you change this to maybe single quotes, this thing, this will still work. So this will still work. Okay. It doesn't matter how you declare it here. Once you want to, this is actually, by the way, this is called as a string interpolation. Okay. And this is how it actually pitches. But there is one catch here. This is actually, when you use this in a normal way, no, this is string without using those dollar and everything, they are actually just part of the string class. As soon as you do something like this, no, this changes to G string, which is actually Groovy string. Okay, the class itself gets changed. So what I mean by that, just give me 1 second. So hello. If you do something like this, dot get class on this one, okay, and I'll just execute this line of code. Okay, it is showing that okay, I'm from java.lang.string class. So this is the normal string that you have been used to. But let's declare something here. Def a is equals, let's say 30. Okay, and then we'll do hello. My is dollar is, right? And if you do this thing, dot get class here, just 1 second. Let's run these three lines of code here. This is a G string, okay? This is not the normal string. So in Groovy, there are two things. One is the normal Java string that we have used so far, like this here, even this one, without, if as soon as you actually add this variable value inside your method, sorry, inside your string, it actually becomes Groovy string and not your normal Java string, okay? Any doubts so far?
No, Saurav.
Okay. Okay. There's this concept of mutable and immutable. Okay. Let's talk about that later on. Okay. So yeah.
Yeah, Gautam, yes. So I'm saying that if we have used that previous string means without that dollar symbol,
Okay.
so that file we can run from JVM, right? And this dollar symbol file means if that file contains
Okay.
that symbol, we can't run from JVM, right?
Okay. So again, now that is actually a good question. This Groovy is actually built to make Java even more friendly. Okay. So when you are actually, by the way, Groovy is also compiled language just like Java. You might not see it here because we are just executing it directly. There are two ways to actually run your Groovy code. Okay. One is the direct execution that you're seeing this. Another is using Groovy C command, and we'll show you as we progress. Using Groovy C, it first compiles your, let's say you have created hello.groovy file. Okay. When you compile that, you get the hello.class file, right? Just as you get it in Java. Okay. Once you have that dot class file, no, the JVM has no idea whether that dot class file came from Java world or from Groovy world. Okay. So it doesn't really matter whether you're using Groovy string or simple string. As soon as you compile it, it will get converted into a dot class file, and the Java virtual machine, your JVM, will have no idea where that file came from, whether you wrote the code in Java or you wrote the code in Groovy. Okay?
Yeah, got it.
Okay.
Thank
you. Okay. So I'm not sure why this is not working. This is frustrating. Did no? Okay, this is working. Okay. So we have seen this basic data type. Let's actually do some coding part. So I have a simple simple code part where I'm sure a lot of you have seen this already, where you actually swap two different variables. Okay, so if you have, let's say, a equals maybe 10 and b equals 20, how would you go about swapping this two? Okay, so let's actually do this simple code in Groovy first. Okay. So let's define our two variables. Int a equals 10, def a equals to 10, def b equals 20. Okay, and just to be clear here, I'm using def. You can use int, but behind the scene, you have to keep in your mind that this is not just 10 and 20. These are objects with values 10 and 20 in them. Okay, so let's just swap these two things first. Okay, we can create a temporary variable here. Okay, temp equals to, we can point it to a. Then you can say something like a equals b, and then b equals a. This is a very simple code, but I have to show you something else. Then you can print line here, print line. A is $A and B is $B. And let's just print this at the top as well, so that we know that swapping has worked. All right. So currently A is 10 and B is 20. Then after swapping this, A is 10, 20 and B is 20. Why? Oh, sorry. This would be temp, no?
You didn't use the temp.
Yeah, sorry. So it becomes like this. Okay. So what I actually want to show you this thing is when you say A equals to 10, okay, what actually happens that A itself is actually not equal to 10 by any means. Okay, we are not in the primitive world, we are in Groovy world where everything is an object. So you have to think in that terms that A is not 10. A is a pointer to 10. Okay, if I can draw hypothetical diagram of your RAM, the random access memory on your system, okay, somewhere there will be 10 here. Okay, I don't know where it will be, I'm just saying. And A is basically pointing to this memory address. A itself is not 10. Okay, A is pointing to this memory address 10. Okay, and when you say 20, B equals to 20, somewhere B equals to 20. B itself again is not 20. Maybe it is somewhere here, we don't know. Okay, B is actually a pointer to the memory address of 20. Okay, so let's just erase this thing quickly. So when I say something like this, A equals to 10, think of in this term. A equals to 10. So A is actually a pointer to this object, which actually contain a value of 10. B, another object, which is somewhere in memory with a value of 20. Okay. Then I said, can we have our code? Let me just go over there. As per our code, we send temp equal to A. So essentially what we are doing here, we are saying temp equals to it. So temp is a new variable that is actually pointing to what A is pointing to. Okay, so this is your temp. Okay, then what we did in our code, we said A equals to B. What that effectively does, again, A is not equal to 10. Don't think in that terms. It's just a memory address to a location where 10 is stored in your memory. Okay, so when I did A equals to B, A will not point to B this way. This is wrong. A will point to this memory address here. Okay, so this gets broken. Okay, let me erase this one. Okay, this gets broken. Now A is pointing to this. What else is left now? B should point to where temp is pointing to. Okay, B equal to temp. So this one will get broken, and this will point to where temp is pointing. Temp is pointing to this memory address. Okay, so what we are essentially doing is we are not changing the value of A and B here. We are basically doing this change of pointers, to be honest. Let me get rid of this thing. It is very important that you start thinking in terms of objects. Okay, and that everything is an object, and that A and B itself, they are not the value itself. They are actually pointing to somewhere in memory, which is having those values stored in memory. Okay, so they are just the reference, if you can think in that terms. Okay. All right. Okay.
So I have a question here, Saurav. So if you specify a value to a variable and then it's something like a string where it is immutable, right? So same thing, it happens to the every data type here in Groovy. Is that right?
Sorry, I didn't get you. Can you come again?
So what I say is it's becoming every data type is becoming like an immutable object, right? So immutable, something like a string, how a Java string becomes, right? That is the way it becomes, right? Okay. So if you specify multiple values to it, so what happens is only the object gets changed and not the value gets changed, right? So is that?
Yes, to be honest, yes.
Okay.
Yes, that is true. Okay. Does it everybody understand this compilation, immutable, mutable, and what we are talking about? Because if you don't understand, I can show you exactly. I think some of you actually don't understand. So do you want me to go through it?
If you can explain a bit what is mutable, immutable, so that will be
nice. So I get that, because when it was difficult for me, so I'm not sure. Okay, let's talk about mutable and immutable. Okay, mutable and immutable. Now let me clear this up. Okay, mutable and immutable. Okay. Mutables are those objects. We actually let's discuss immutable first. And by the way, when it comes to immutability, people start thinking in just strings. Even your integers are immutable. So what I mean by immutable? So let's say I did something def a. I'm not using def, by the way. I'll use int equals 10. Okay, int a equals to 10. It's a simple integer. The thing is, with immutable objects, once you create it, it cannot be changed. Okay, so once this a has been created, okay, let me just get my annotation. Yeah, once you have created this, okay, once you have created this, it will not change. Okay, now you may wonder, let me change it for you. Now you may wonder this thing about this. You'll say something like, hey, a equals to, let me print it for you first. Print line a. Okay, and by the way, this parenthesis is optional in Groovy, and we'll discuss this when we discuss methods and all those things later, but let's keep it this way. So if I run this, a is 10, then I said, hey, a equals to 100. Okay, and then print it out this way. Okay, it changed to 100, but I'm saying it's immutable. It shouldn't change. So what is happening behind the scene exactly? And for that, we'll go back to our this thing. Where's that? Let me go back to my whiteboard. All right. So I just showed you this. When you said something like a equals to 10, it was somewhere in memory that you had created this, right? something this. And A is not 10, right? A is a reference. A is a reference to a memory address where 10 is stored in your RAM. All right. So 10, let's say 10 is here. Okay. A is basically pointing to this thing. Okay. Now I said somewhere in my code, hey, make A equals to 100. Okay. This did not change here at this memory address. Somewhere, I don't know where, because we don't play at a lower level that much. So somewhere maybe here, 100 is created, a new object is created in your memory, and this A starts pointing to this thing now, and this is gone. Okay, so this thing was already there and it didn't change. What you have essentially done is you have pointed now to a new memory address. That is immutability in a nutshell. It doesn't change. You are just pointing to a new memory address. Okay. So let me just get me one thing. Okay, so I'll show you by code also that what I'm saying is actually true and not. Let me clean this. 1 second.
Saurabh,
Yeah.
so isn't it something like the value assigned to that memory has been changed?
No, you actually created it at a new place. Okay. This is actually created at a new place. So I'll show you. Just give me 1 second. So let's just print line. This is, by the way, coming from, again, there is something called as hash code that each object has in Java. Okay, so we'll try to print that. Don't think about hash code and all those things. Just think it that this is just going to print me a memory address. Okay, so system dot identify hash code. Okay, and we'll give A here. Okay, and we'll, sorry, I messed up. Cancel. What is happening? Okay. Okay. So if you run this, no, sorry. What is happening? System not identified, it's identity hash code, sorry. Okay. Again, it is throwing an exception.
The typo in the.
Yeah.
Identity. Okay. Sorry. Okay, I can type. All right. So as you can see here, okay, the hash codes has changed actually. The memory address had changed. It's not the same pointer. So initially, let's say, initially, this A here, right here, was pointing to, let's say, this particular thing, okay? And when you said change this value to 100, it didn't change at this memory location. It created at some place else, and then it is now pointing to this. This A is now pointing to this. Earlier it was pointing to this one. Now it is pointing to this thing, okay? So this is immutability. The value will not change. You will just point to a new memory address. That's it. Okay. So it looks
So
like,
if
yeah.
so if we add B as a 10 and we'll
Sorry?
check that hash code of B, so what will be the hash code of that?
So if you, okay, so I get you where you're coming from. So you did something like A is this thing, okay? And now you are saying basically B equals to A. Is that what you're saying?
No, I'll B equals to 10
Okay.
and check the hash code of B.
Just a minute. Okay. B, okay. And if you run this, it is actually pointing to the same memory address, okay?
Yeah, got
It is pointing to the same. Actually, there's something called as what do you call that? Singleton pattern. Okay, so I'm not sure about how Groovy works in behind the scene, but once you create an object of a certain thing, not for all the numbers, but I think in some range from 0 to 256, something like that, it will actually point to the same memory address. So this actually does some kind of optimization, and there is only one object, only one instance of 10 that is in your memory, and all the memory addresses, all these A, B, C variables, whatever you have, is pointing to the same memory address. Okay.
So Saurav,
yeah.
okay. If it is just a pointers, okay. So how this memory is getting those values? Someone has to insert those values into that memory, right?
So I didn't get you. So
So
if
you are just saying that A is pointing to the memory which is having the value 10, correct?
yeah.
Okay, and when we make it A equal to 100, the pointer has been changed from 10 to 100, where the 100 value is available.
Yeah.
So, but we are just changing the pointers, that's it. Okay, but the memory should contain those values, right? Okay. So how to insert those values in that case?
Okay, so I think this will get more clear when we talk about object oriented, but I'll just show you one thing here. Okay. Let me get my eraser. Okay. When you say something like this, no, when you're saying A equals to 10, okay, very simple stuff. I have told right from the beginning, this 10 is not a primitive simple 10. It is an object. Okay. And how do you create an object? It is created on your memory. Okay. This actually Groovy takes care of creating this thing. Okay. Somewhere it will create. You don't know where it will create. Somewhere it will create in your memory. Okay. A will just point to this 10 wherever it has been created. Okay. It will be this is taken care by the compiler itself. We cannot actually assign a certain memory address to any variable. This is done by compiler. Okay. But this creation of this thing, the creation of this 10 or 100, whatever I have told earlier, once you actually okay, I'm not sure how much you are familiar with object creation, but if you know a bit of coding, you will know that when you say new dog something, okay, dog equals to new dog. We'll talk about this as we discuss object oriented. When you say new dog, no, this thing, new dog, it actually creates a object in heap actually, which is where objects are stored. But think of it in this term, that when I said new, an object in memory is actually created somewhere around this RAM area. This has been created by the compiler itself. Okay, this new is the thing that actually creates an object for you. So here it might not be that obvious to you when I say A equals to 10. Okay, yeah.
New is a keyword.
New is a keyword. A lot of things are a keyword. But when you say A equals to 10, no, okay, behind the scene something like this is happening. Okay, it is left this way so that a beginner can start to code in simple terms. A beginner or even an advanced developer, they can start to code in simple terms. Like I don't have to write something like new integer, something like that. I think that should work. Let me just
okay. So behind the scenes, if the value is not available, instead of changing the pointer, it will create that value at the in the memory.
Yeah,
and it points to that.
Yeah, it will make the variable point to that memory address. Yes.
If it is already available, it just uses the same memory.
No, not always. I'm telling you, not always. That is a special case with small integers. Okay, that will not happen every time. That is special case with small integers. Okay. Forget about that. Actually, that is because that is something related to designs. Okay. So let's actually create this thing, integer C equals to new integer, and this should be 1000, let's say, and then I'll simply say print me this thing C. Okay, and if you run this, it will create like this. So essentially what this is doing, no, when I'm saying new, that means create a new object for me in memory. Okay, and make this C point to that memory address. Okay, So this actually in a nutshell, this is actually in C equals 1000 would do the same work for you. You don't have to write this every time. This is enough. The compiler will understand, yeah, I'm going to create a new object for you, and that will have a value of 1000, and I'll make C point to that memory address. Okay. I hope that clears out. All right. Okay. That is immutable, by the way. The value itself does not get changed. What we are essentially doing is that we are pointing to a new memory address with the new value. So even for a string s equals something like, let's say, sort of my name, and then you can go ahead and print line this. Again, I'll just copy from here. Print line. Okay. And we'll just give s. All right. And then I'll point s to some other address, maybe some other value, and we can copy this. We can run this. All right, they are different memory addresses. So that is what I mean by immutability. Okay, the one where this s was pointing to initial. Okay, this s, it is still there in memory. Once maybe the program finishes execution, that gets cleared off from memory, so that it is the memory space is available for other application on your system. But when I said s equal to Saurabh, this was pointing to this memory address in RAM. And when I did s equal to Kumar, it didn't paste, it didn't actually refer to the same one. It actually created Kumar at a new memory address and pointed to that one. So that is what is meant by immutability. Okay.
So
Any
hello.
question? Yeah.
Yes. So when we use this variable like s, okay, to call a method, suppose size is there, right? We have one
Yeah.
method.
Yes.
So which variable will call like?
Okay. So when you're saying print line s dot size here, okay,
Yes.
this is what you're saying, right?
Yeah.
So till the time you are actually having s point to again, let me get my marker 1 second. Till the time you're pointing to this one, okay, whatever calls you are making will be done on this one. Okay. Once your s started pointing, remember I told you it's just a pointer. So either it can point to a reference at, it can point to a certain memory address or to some other memory address. Okay. So it was initially pointing to this memory address. When you say, hey, get me the size, it will get you the 6 because there are 6 characters there. Once you started pointing to this memory address, okay, all the method that you run, size or anything for that matter, will work on this string. Okay, so here it will get you 5. Okay, so if I can just code it here again, let me get the size. And if you run this, it was 5 initially, and then sorry, it was 6 initially, and then it became 5. Okay.
Okay. Okay.
Let's clean this.
So one more thing.
Yes.
So in this code, we are pointing yes to the Kumar, right? Okay.
Yeah. Yeah.
And we are I mean, it's a kind of a declaration, variable declaration. Okay.
Okay.
So in the next code, okay, which is not related to this one, I started writing another code. Okay.
Yeah.
And I didn't declare this s equal to Kumar, and I directly print this println this yes. Okay. So in the behind the scenes, will it store still it will store that Kumar as a value to this yes?
Again, you are thinking it wrong. I've told you that these variables, what you have here, okay, they are not storing anything. These are just pointing to certain memory address. As soon as we did this s equals to Kumar from Saurabh, we changed it to Kumar, it stopped being pointing to a memory address, this one, okay, and it started pointing to this one, a new memory address. Okay, it is s itself is not Kumar. S is not equals to Kumar. Do not think in that terms. Okay, s is not equals to Kumar. S is just a memory address where Kumar is stored. Okay.
Okay, so I haven't given there. Okay, I just printed that println yes. Okay, in that case, whatever the pointer last time it is assigned, will it give the same
Yes.
value from that address?
Yes, it will give you. So if I did print line here, S, and if you did here also, so that it is clear for everyone. So if we did this, sorry, think I'm doing something. Okay, I didn't write something here. Okay. Okay. If you run this, it is currently pointing to Saurabh, so it gave me Saurabh. It is now pointing to this memory address where Kumar is stored now, so it will give me Kumar. Okay.
Okay.
All right.
Prasad, to add more information to what Saurav said, right? So what we can do is we say, for example, S equal to Kumar, right? You can even have T equal to Kumar or V equal to Kumar, and you print the identity hash code, it will get the same object value. So that proves that it's an object that is getting pointed to, not the actually value. So that proves that will prove the immutability of this class actually.
So actually what my question is, okay, so we are already pointing right now S equal to Kumar, okay, in this code. So I started writing a new code, okay. I didn't pointed anything to the S, okay. I haven't declared that one at all, okay. And I started directly printing that println yes, okay. So will it pull out the last pointer which was did last time or not? That is what my question is. I mean, in the new code also, will it give that S equal to that Kumar value or not?
Okay, Saurav, so it means that after the execution of this program, the value would be lost, right? So to answer his question, then if it is part of the same execution, then the value would be will be still will be held, right?
Okay, I get it now. I get it what Prasad is saying. So okay, so what Prasad, you are essentially saying that once we are done with this all this code over here, okay. Will it still work if we do later on S equals to, I mean, if we print.
Yeah, will it still hold that pointers or not? That is what my
No, so let me just get rid of this whole thing. Okay, okay. Let's get rid of it. Because you are thinking, I get it what you're thinking. So let's just go here. Hey, open up. Okay. So again, somewhere Kumar is stored, right? Okay. And then your program execution is done. Okay. That is not how our operating system works, Prasad, honestly. Once you are done with program execution, no, this, whatever these things were referring to. So let's say this has 100 variables. So it will refer to a lot of places in memory, right? All those things will get cleared out. Okay. Because maybe some other application need those memory. Okay. So it will not have Kumar after your execution is over for the current code. Okay.
Okay, got it. So in the backend, it is not, I mean, it is not storing those pointers actually. Correct, right?
For the current execution.
For the current execution, it is storing, but
yes,
once after that, it is not storing those pointers.
Yeah, because think in that terms. No, so you have a 4 gigabytes of memory, right? 4 gigabytes of your RAM, let's say, and I declare something like maybe a million variable I'll declare in my code. Okay, and each of them will take let's say each of them let's say they will take maybe 16 bytes or 32 bytes of space. So in just like all those variables will already take enough of space in my memory. So once my execution is over, those memory needs to be cleared out so that the other applications such as Google Chrome or your Microsoft Outlook, whatever, they can use those memory. Remember that Chrome, Microsoft Outlook, all these are programmed, and behind the scene they're actually pointing to memory addresses to get your work done. Okay, so if you just kind of get all this garbage value in your RAM, okay, and if the code, once the code execution is over, if this doesn't clear out, then you have a chance of running out of your memory very soon. Maybe you'll write 5-6 Groovy code, and they will each use a million or billion of variables, and this memory will get filled pretty much very soon. Then what happens later on when something like Google Chrome or Outlook needs to boot up, right? They will not have anything left to point to in your memory. So once your actual code execution gets over, this will get cleared out for sure. Okay.
Okay.
All right. Let me clear this. Okay. So that is actually immutability. Okay. Let's actually do immutable ones now. So we'll discuss collections as we move forward in our classes. Let's declare this thing first. Okay. 1, 2, 3. Very simple. Okay. List is just like an array. Okay. It instead of earlier we were saying int a equals to 10, int b equals to 20. Okay. But what if there are a group of numbers that we want to work on? What if there is not just one value, but a group of value that we want to work on? That is where we use something like list. This is like behind the scene. It is actually an array list. Okay. But let's not go there. Okay. Mutable and immutable we were talking about. So I will go ahead and print this thing again, print my list, and I'll also do something like print my system dot identity hash crew, right? And let's pass this list here. Okay. Okay, and this is pointing to this memory address. Okay, what we will do, I'm saying list is mutable, so it can change. Okay, so list dot add is a method on a list which is actually used to add numbers or anything else to your current list. Okay, and let's run these two things again. Okay, you can see that they're actually pointing to the same memory address. So if I could take my this thing again, we can go here. Okay, so let's say a list variable was pointing to this memory address, and this has like 1, 2, 3 initially. Okay, when I said list dot add 4, right, I added 4, it will not create a new memory address down the line or anywhere. Okay, what it will do, it will create it here itself. It will just add it to the same memory address. Okay, this is actually the essential difference between mutability and immutability. Okay, mutable things changes. Okay, immutable, they don't change. You point to a new memory address. That's the only difference. Okay, is that clear?
Yeah, it is. Yeah.
Okay.
Yes.
Okay. All right. Okay. Let me just, for the sake of completeness, just let's do.
In which scenarios mutable and immutable words? Suppose you were adding the pointer to that word, right? Suppose if you are deleting, in which scenarios it's mutable words? Only for adding the things to the same pointer?
No. There are certain objects that are mutable and certain objects that are not immutable. So
Okay.
list is actually mutable. We have something like dictionary or maps. Those are also mutable.
Okay.
So when I say mutable, it changes at the same memory address. That's the only thing about mutability. And when we say something like immutable, so when like we have done on earlier also for integer and string, it actually, when you change the value of your string variable, it actually starts pointing to a new memory address where the new object is created. Okay.
Okay.
So any questions so far? Anyone?
Do we have a similar thing like a string buffer is in Java, right?
Yeah. But anything that you have in Java is also in
That's
Groovy.
it.
Anything. Just to be clear, we can do this thing, system.out.println. Hello. This looks like Java. Okay, and put a semicolon. Why not? If you run this, it will run. Okay, so Groovy is not to actually replace Java. You can actually use exact same code that you have used in your Java code and it will still run. It is so much deeply integrated. They call it as they are integrated in a tongue and groove fashion. Okay, so even there is this thing topic in Groovy where they call it like my class is your class. So let's say I have 5 classes in my current application. 2 of them can be Java, 3 of them can be Groovy, and the JVM will have no idea that which one was written in Groovy and which one was written in Java. So
Thank you, Saurabh.
yeah.
Saurabh, can you show the last code you have written on list?
Okay, I actually deleted that. Let's see.
Okay. So like when I'm trying to add, I'm getting error while printing the like.
Okay, we'll come to list maps and all those things.
Okay.
I was just showing mutability and immutability. That's the difference. Okay.
Okay.
Yeah. So far, any doubt here? Okay.
I have a basic doubt here, Saurabh. So
Yeah,
how do you organize it? For example, in Java, right, you create a class and you save it as a class and then reference that class from another class, something like that you do. The same way you do it here as well, or how do you organize the code?
Yeah, you actually organize very similarly to Java actually. Okay, so
Okay.
there are things Groovy actually is not just for object-oriented thing, it is also used for scripting language. Okay, so let me show you a quick demo. So if you have a class, let's say dog, all right. Again, we'll talk about this for guys who are not familiar with object-oriented. String first name, there's no first name for dog, sorry. String name, right? And this you cannot do in Java, by the way. Def dog equals new dog, okay? And this will work fine, okay? For this to do, you actually need to go to your main class and you have to do something like inside a public static void main, you'll actually create your objects and then interact with your other objects, right?
Yeah, that's right.
Here, Groovy is actually not just object-oriented, well, it can be used as a scripting language. So if I have to do it here, we can do it this way. I created my class and just below that, I can run this class and this should work fine, okay? And it prints me, oh, dog is at this hash code, something, blah, okay?
Okay.
Again, you can do public static void main also if that is what you want, okay? No restriction.
That defeats the purpose of Groovy, right? If you have public static void main, no?
Yeah, actually, yes. This is actually better. This is more like Pythonic in nature, where you create your class and then you can start working with that class object right away. Okay, so we'll discuss this as we go over to object-oriented side.
Okay, thank you.
Okay, and just for completeness with Java and Groovy world, let's actually there's something called as index of in string in Java. So let's say if I have abcde dot index of, right, and I said something like 67. Okay, very simple code. So what it is basically saying is this is a string, okay, and I want to find what is at the index of 67, and 61, this is the ASCII value, ASCII or whatever you call it, and 67 stands for 67 actually has this C character. So if you run this, okay, it will print you 2 because by the way, it starts from 0 index. So this is A is as 0, 1, B is at 1, C is at 2. So it prints me 2. Okay. So if you just think it in terms of Java and Groovy here, okay, a lot of things are happening. We are running this from exactly where? We are running this from Groovy, okay. What is this? Index of, this is a method in java.lang.string class, okay. And java.string.lang class takes, okay, let me show you what I mean by that. Just give me 1 second.
So you mean this one extends the java.lang.string class?
Yeah, you can see that, but there are a lot of things happening at this position here. Let me just open the API for string index of API. Anyway, we'll open that only. Okay. So this is having somewhere it should have a controller index of, right? So as you can see, it is overloaded. I will talk about overloading in a later on when we discuss object-oriented thing. Okay, so this is the API. Okay, this is the public API for your string index of method. Okay, this accepts an int ch, which is actually an integer. Okay, and it returns an integer. That is what it returns. Okay, so what is happening at this simple piece of code? Okay, let's take this to here. Sorry, I will discuss it here only. Okay. Okay. One second.
Hi, Saurabh. So one question. So what is 2 here? So the position of C, right?
Yeah, 2 is the position of C. And by the way, strings are strings or list or anything will start from 0, just like
0, 1, 2, 3. Okay. 0, 1, yeah.
0, 1, 2, 3, not 1, 2, 3, 0, 1, 2, 3. Yes. Okay. So let me just actually yeah. Let me get me some rules to work on. We have seen that this method index of accepts an integer. Okay, and it returns an integer also. Okay, when you pass this 67, what you are exactly passing? Are you passing 67? No, you're actually passing an object with a value of 67. Okay, once you pass this is not like your int, rather this is integer, the bigger one, which is the wrapper class. Okay, now this integer actually gets converted into this int. So there is this how can you show you that? Are you guys, anyone here familiar with the concept of unboxing and boxing? Anyone? Hello?
I know what's boxing and unboxing is. Yes.
Okay, but a lot of you don't know. So okay, let me just summarize it at a high level. So I'll just get everything. So we have seen here that this actually accepts an integer. Okay, this index of method, and it has got a return type of integer only. Okay, and we have here we are passing 67. This, by the way, is not your typical primitive int. Okay, it's not just the value 67, it's an object with a value of 67. So this call is not just happening at Groovy level. When I'm calling index of, it actually calls the Java's index of method. Okay, so when it actually calls the Java's index of method, this 67, which is currently an object, because in Groovy everything is an object, actually gets converted into primitive int. Okay, so from object 67 it becomes plain primitive 67, and then index of method works on that, and it returns 2, this 2 here, this returns 2, and when it enters the Groovy world from the Java world, okay, this 2 again gets converted from the int 2 to object 2. So I know that makes a lot of issue. One second. So let's say this is my this is the boundary. Let's say, okay, I have Groovy code here and the Java code here. Okay, when you say index of 67, this 67 is actually an object. But when it comes to this one, index of here, because this index of is this this particular index of is not available in your Groovy development kit. It is not there. You have to call the Java's method on string. So when you call this index of from Java world, Okay, this object actually, which is an object, think of this like an object. If I'm circling it, it's an object. If I'm not circling it, think of it as like a normal value. Okay, so this 67, this object, when it enters this Java world, it actually gets converted to a simple 67. Okay, because that is what this method expects. It expects an integer. It doesn't expect an integer object. Okay, then it does the work for us. Okay, it finds whatever is at the index of 67, and then it returns back an int, which is 2 in our case. Okay, so sorry, I circled it. I shouldn't have circled it, by the way. So this is the normal 2 that we are dealing with. Okay, the normal number 2. And then when it enters into the Groovy world, it actually gets converted into an object with a value of 2. So this is actually called, when you convert this object to a normal number, this is actually called as unboxing. Okay, an object is actually converted to a normal number. It is called as unboxing, and the opposite part, that is from the normal value, when it is converted into an object, it is called as boxing, and together it is actually called as auto boxing. So Groovy takes care of all of this for us, but behind the scene you have to keep in mind a lot of things are going on. Okay, all right, any doubt on that?
Yeah, I suppose I given the index of 678, suppose, for example.
Okay.
And then, yeah.
You're giving this, right?
Yes.
Okay. The 678 is not here, so maybe it will return -1 or something. I'm not sure. So let's just figure it out. -1. It's not there, so it will return you -1.
Okay.
If it is there, then you'll get that index.
Okay. Yeah.
Okay. All right.
Saurabh, how exactly it is converting to that 678 to -1? So you said that into 2 it is converting to integer. Okay, that is fine. So I understand that. But how it is displaying this -1 value for that 678?
Okay, 678, you're passing this, think of this as a ASCII value. If you have seen ASCII value, it starts again. 65, for instance, is for character A, 66 is for character B, capital. Okay, so this is basically you're passing the ASCII value, and you're expecting in this particular string whether that value is there or not. If that value is available, it will return the index of that. Okay, so when I was passing initially 67, or let's say 68 we are passing. Okay, 68, by the way, stands for your, so let me just keep it 60 ASCII for 68 is D, capital D, not the small. I think the smaller one will be around 101, something like that. Yeah, so ASCII for 68 is D. Okay, so when I search for 68, it will search in this string that I have provided. Okay, and it will check if that character is there. That character is there, D is available. Okay, and it will print out, okay, the index of D. What is the index of D? It starts from 0, 1, 2, 3, right, that way. So it is at 3. So if you print this one, let's print this, it is at 3, right? If it is not there, so I am saying I have, okay, this A is at 65, right? You know, this A is at 65, B is at 66, C is at 67, D is 68, and E is 69. Okay, if I give 70 also, no, this will return -1, because 70, for 70 you should have what exactly? You should have F.
F, yeah.
F should be there. F is F available in this? It's not there. Okay, so it will just return me -1.
Okay,
it is a way, so you can check it in your a code, general code, like whether that thing is available or not, something.
got it.
So when there is no reference of an object matching this, then it will be -1, right, Saurabh?
Yes, it will be -1. If it is not there, it is -1. All right. Let's move on. There are methods on, so we are talking about data types, so we'll continue with that. Data types. So there are a lot of methods on int, strings, and all these data types that you have seen, even the booleans, double, float, whatever is there from Java world, you can use it, but Groovy has all these things available as well. So let's say if I want to do something like, what do you call that? Something like round method. Let's say I have double d equals 2.4, something like this. You can call this, right, d dot round, and then if you run this, it will just round the value, this thing from 2.4. What does happen? Okay. Similarly, there is a lot of method that you can call. So if you have a string and that is having a number, like say 2.345, something like that, then you can say this is a string, by the way. Even though it seems like a number, we have put it in inverted comma, that makes it a string. Okay. So you can check, is it a number or something like that? And this will return true, because yeah, 2.345 can be converted to a number. Okay. So there is that. All right. If you want to do something like, let's talk about some operators also while we are dealing with number. So if you want to do something like division, by the way, division will give you a decimal value, and in Groovy, I have told it is not the double or the float that is the default. It is actually big decimal. So if I do something like divide maybe equals to, let's say, 9/4. Okay, you can print line this thing, print line divide, and it will be something. I'm not really sure what that is, but this, it is 2.25. And if you just go ahead and print the data type, it will tell you that it is actually dot get class. It is actually big decimal and not float or double. By default, it is big decimal. Okay. If you want to do integer division, again, if you want to do integer division, let's say int division, something like that, you can do 9.intdiv. Okay, and 4, and then if you run this code, you'll get the value as 2. All right. That is how you do integer division. If you want to get something, let's say if you want to get the remainder, again, the remainder works as it works in other programming languages. So the remainder equals 9%. 4% is the operator that we use for that. So this will actually give you 1, because when you divide 9/4, 4 goes 2 times, which is 8. 9 minus 8 is 1. That is your remainder. And be careful when you are dealing with negative numbers. So you might not think that it will print -1. It is printing -1 for the time being. But if you deal with some different number, maybe let's say if you deal with 135/4, it will print you something like that. So when you're dealing with negative numbers, be careful with a remainder operator. Okay. What else? All of the things that you can do in other languages, you can do it here, but Groovy adds a lot of flexibility. So let's just define something. String, let's say str equals to, let's say, some random thing, maybe anything. Okay, 1, 2, 3, let's say. Okay, so we can do string addition just like we have done, just like we used to do in Java world. So I can do something like print line str plus give me 4, 5, 6, and what it essentially does, it will add 1, 2, 3, 4, 5, 6 together. Yeah, so if you run this, you have that. but this is common and this is across many languages. But what Groovy offers you is some other things as well. So something like you can do something like print line string times 3. Okay, so if you run this piece of code, these 3 things here, it will do 1 2 3 1 2 3 1 2 3 3 times. Okay, so you can use something like this as a line separator if you're maybe doing some kind of debugging. So you can add something like this thing times 40, and this will multiply this thing 40 times, and this will act as a separator between your code output on console. You can also do something like string subtraction as well. So that is not common in any language that I've seen, but Groovy offers you that. So what I mean by that subtraction, just a second. Yeah, what I mean exactly by that is that if I have something like Saurav, right? Saurav, okay, then I can remove this character from this. So if you do U, okay, and if you run this piece of code, it says it remove that U from this. Okay, so this subtraction is also available in Groovy. Okay, and if you do, it will just remove the first instance. It will not remove all of it. Okay, you can write your own code for that. All right, so that is some basic operations on this data types. Okay, now the booleans, I have already told there are only 2 values in booleans. So boolean flag equals it can be either true or flag can be either with false. No, there are not a lot of things in boolean. There are only 2 things, 2 values that a boolean variable can take. Okay, we'll use these booleans as we go through our coding examples. Okay, is it clear so far?
Yes.
Yes.
There are a few things in strings like line separator and all those things. Okay, we call it as skip sequences, skipping special characters. So when you're doing print line, okay, and I did something I sort of maybe let's change something to Oracle as an enterprise, maybe, right? Something like that. So if you're adding a slash or something, okay, you have to kind of skip it, and there are, if you just add this, let's run this piece of code, it will blow up. It said that some unexpected thing has happened because this actually acts as a escape character. So if you have to escape something, maybe if you want the slash to appear in that line of printing, in this print line, you have to give it to slash symbol. Okay, so if you run this, and this slash will come. Okay, similarly, if you want print line, maybe Oracle /n is /n and /n enterprise. Okay, so if you run this piece of code, /n is basically for new line. Okay, so if you run that, it will every /n that it encounters will go to a new line. Okay. We can do some basic operation on this thing string as well. So if you have a string declared, let's say is equal to, we'll declare it Oracle. Okay, you can just say something like s dot starts with. There's a method on string where you can say, does it start with, let's say, O, and if it does, it will say true. But if you give something like B, okay, it will blow up. It will say no, it is false. This is starting with O, not with B. So you get something like a false result there. And there is extensive documentation, by the way. You can go to this and just go through a lot of things. This documentation is quite, it is better than Java's documentation, to be honest. And you can just go through it and figure it out. If you go here, just 1 second. If you go to syntax, you have all this a comment over here, like how do you do single line comment, multi-line Groovy doc comment. There's also called shebang. Okay, shebang comment, like this is specific for Linux system where this thing is there. So this is treated as a comment as well, but this is specific for Linux. Okay, so do go through the documentation. We can also do, I have already told that the string starts with index as 0 all the way through the length of the string. So you can do something like S0 and this would fetch you the first character, which is O here. Okay, so if you run this, you'll get O, because string arrays start with 0 index and not 1 index. Okay, so another example is, can we let's say we have this S equals to something here, let's paste it here, and I want to fetch the index of, again, we have that index of method available from Java world. So you can do s dot index of, I want to see what is the index of C. Okay, so you cannot write C this way, by the way, and this will again, this will blow up. And why is that? Because we have not defined exactly C. Okay, so you have to put it under inverted comma, and then if you run this, it will say, okay, C is at the 3rd index. Remember that it starts from 0 index. Again, there is another method which you can use to figure out whether it contains something, like s dot contains. This is useful when you're doing reading files and all those things, like maybe you're going through a file, reading line by line, and you want to see whether that particular line has certain content in it. So you can do that. So for Oracle, I'll say whether CL is available or not. Okay, and it is there, so it will say, it is true. Okay, so these are the methods that we have. There is another concept of this is actually taken from Python. So you can actually get the slicing. This is called slicing. I'll show you in a minute. So I want something like this. Okay, so what it essentially will do is, if you run this thing, it will get you from 1 to 3. Okay, so what I'm saying, fetch me the value from the first index up to the 3rd index. So 3rd index is inclusive here. Okay, I think this thing, if you do this thing, it will not fetch. This is called half exclusive, and we'll talk about this. Is actually ranging range. We'll talk about that when we discuss collections. Okay, I'm just showing it here for the completeness of this data type and all. All right, so let's say I have a new string that I define here. So I'll say string string str equals to, let's say, hello Groovy. Okay, then you can do something like hi, and then plus str. So what it will do, it will add hi to this thing. So just let me run this for you. Hi, hello Groovy is what we are coming up. Okay, but I want to remove the hello from this thing. Okay, so what we'll do, we'll remove hello. Okay, so you can do this kind of operation as well. So it will print from, it changes from hello Groovy to hi Groovy. Okay, then there is something called as the count method, that you can count a particular iteration. So if you have this string here, let's just copy this. Okay, so I can say string dot count, give me the value of how many times O is repeated in this string. Okay, so if you run this, it will say O is repeated 3 times. So you can use these methods as well, and these are fairly documented on the website API, so you can check over there as well. Okay.
Saurav,
Yeah.
why we getting this like single string?
Sorry.
Can you run these two, like 13 and 14th line?
Okay. Yeah.
So in the output, we should not get this single string, right?
Yeah, it doesn't really matter to us whether you're getting single or double. It's okay.
No, or like
Everything. Yeah.
like it should be simple string, right? Without any quotes.
I'm not getting you. So you are saying, okay, so if I have a string, let's say,
If you are printing some name like my name or something, any name, so it should be like clear name, right? Or
okay.
why we are getting these like single quotes?
You wanted this, right?
Yes, yeah, exactly.
Because here I'm not printing actually out. I'm just getting the value of variable. Okay. So when I actually
So
explicitly,
these are two different things, right? Like
yeah. So if you can come here, I think somewhere it is there. So you can run a selection, Control-Shift-R. That is what I'm doing. Okay. So when I have something here, I want to only show this code, not the whole thing that is I worked with. Only these two. I will just select Control-Shift-R on these two. I select whatever, I highlight whatever I have to run, and it will just run for those 2 lines of code. Okay.
okay.
Yeah, and I'm not, by the way, printing this. I'm just extracting the value of the variable that we have. Okay.
Okay.
If you intentionally print this thing,
Then it should
if you actually print it, print line, this particular thing, yeah, it will not show you that.
okay, got it. Yeah.
Okay.
Okay,
So,
thanks.
okay. Anybody any doubt? Okay, so there is I talked about G string earlier also, which is your Groovy string. Okay, and by the way, G string and strings are very different. They all have separate parent in their object hierarchy. Okay, so whenever you are referencing a variable inside a string, it becomes a G string, right? So there are few things, good things about G string that you can do. So let me just show it quickly. So I have a variable here. Let's say I have it as my age is something. Okay. So you can do this. If I print the type of this object, it will show that this is currently Java.lang string, right? But you can do you can insert something like, let's say, in is 32 32 or whatever. Okay, so you can come here and you can use the $sign. Okay, and by the way, you have to be in double quotes or triple quotes, not single. This will not work with single quotes. Okay, you can say age. Okay, and now if you run this, notice that this is string currently because I hadn't used this string interpolation, the variable inside of the string method. So if I run this, it becomes a G string implementation. It's actually a G string. Okay, so this is now a Groovy string, and it will print out exactly what I needed. So if you print this, it will say my age is 32. Okay, but you can do more with the Groovy string. So you can also write expressions there inside of a string. So what I mean by that, so if I had a string, let's say this is weird, and here you can say $, right? Now for expression, you have to put it in under curly braces. So I will say 2 times 3 plus 10. Okay, if you run this piece of code, it will actually get the value. It will evaluate that expression, and then it will give you that final output. Okay, so if you are evaluating in a string, if you are evaluating an expression, you have to use this curly braces. Okay, if you are simply using a variable, it's optional, but since that would be a good practice to always use it, I would recommend to use it every time. Okay, so just for using variable inside your string, the curly braces is not required. But if you're using an expression evaluation inside of your string, then go with you have to use this $. If you don't use this, what it will do, it will blow up. It will tell you that you are using something it will ask for this too, like it will try to evaluate this variable here, but that is not what you intended for. So if I run this, it will blow up. Okay, recognition error. Okay, recognition error at 2. Okay, because it is not able to wrap its head around like what 2 exactly means. Okay, so for an expression, you have to use this curly braces. And by the way, these strings are also immutable in nature. So even if you change, when you change, it will point to something new. Okay. There are more methods that we can actually work on, which requires the use of closures. Just a second. So we can say something like 10 dot times. So and I'll explain to you closures in a lot more details when we talk about this thing. So println it. Okay. So what this code will effectively do, it will run from 0 through 9. Okay. So it runs 10 times, and there are other methods as well. Something like 1 dot up to 5. Okay. So it will go from 1 through 5. Okay, so this times method actually starts from 0 and goes all the way, but not including 10. This will start from 1 and will actually go till 5. So if you print this part, print line it. Okay, this will go from 1 to 5. All right. Similarly, there are other things also like down to and step. We'll talk about that. But they actually use closures. I'm using closures here. Closures are just they are like lambdas, in a sense that it's just a piece of it's a block of code. Okay. But we'll discuss closures in great details when we actually use it, because even in everywhere Groovy is filled with closures, so we will discuss closures in great depth, but here I'm just discussing it because I have to wrap up this basic what do you call that, basic data types that we are covering, because you can use this methods on using closures. 2 down to -2, maybe -2, and then you can print on it again. So this is like a reverse from, you're starting from 2 and all the way from minus up to -2. So let me just go around this. And then there is again something called as a step. Okay, so 0 dot step. A step up to 0. Let's say 5 in a step of 0.1. So if you run this print line, if you run this, so this is saying start from 0 and take a step of 0.1 each time up to 0.5, but don't include 0.5. Okay, so it will take 0, 0.1, 2, 3 and up to 0.4, because at 0.5 it will terminate. So that is some more methods on your classes, number class. Okay. All right. Any doubts so far? Hello?
Nothing from me, Saurabh. It's good. Yeah.
Anyone else? Any doubt?
No, sir.
So
Okay. So I'm actually, we have like 12 minutes left. I don't want to start with collections yet. Okay. So what I'll do is I'll talk about something called as interpreted versus compiled language. Okay. Maybe does anybody knows how to this thing compilation and everything? When you have this Java Groovy file, okay, when you compile it, you actually get another file in your okay, it's better to demonstrate. So let me minimize everything here.
Do you want to show in the background of what happens when you run and compile it? What happens?
Yeah. Let me just create a very basic class. I'll show you guys here. So I will just start with the hello dot Groovy. So we have a Groovy extension, by the way. So this is my hello.groovy file. We'll just write a simple code here. Okay. Very simple print line. I'll also create a class for completeness later on. Just give me a second. Hello Groovy. That's it. Okay. Now this class is very straightforward. This is what we have been doing so far. When you run this code, you'll get hello Groovy, right? So let me open CMD. And we'll do here. This is how you run your Groovy code, by the way. You can do hello.groovy and it will print you hello Groovy, right? Because that is what there was in that class. But you can also sort of compile this code and convert into a bytecode. So for compilation, you use the command Groovy C, okay? And when you do this, you'll create a new class here, okay? Hello.class, okay? Now this hello.class is a bytecode. Okay, if I can open it in Atom, this is a bytecode, by the way. Okay, it's a bit random. You will not understand it. This is for the system to understand it. Okay, now this Java, the JVM, the Java virtual machine, has no idea where this class came from. Okay, so this is actually what I mean when you compile your code. It actually creates a new file for you with the same name, but with .class extension. Okay, so again, let me create one quick Java class as well here. Just very simple Java code I'll do. Let's have book. Okay, book.java. All right, and let's open this. And if you don't get it, don't worry. I'll discuss this in object-oriented section as well. So this is how you do very public class book. You give the same name as that one, the name of the file, and then we have just one attribute instance variable, which is the name. I'm not going to go. I'm not going to have a lot of things here. Public book. This is the constructor, by the way. String name. This dot name, and I'll just also get me one thing. One method I'll expose, public method, and this will be like get name. This is a getter again. Okay, public string get name, and here we'll just say, hey, return me this dot name. Simple. So what we are basically doing is we have a book class here, okay, and we have a constructor here, which will be helpful in constructing the book object. And we'll discuss constructor and everything in great depth when we will discuss object oriented. And this will fetch me the name of the book. So this is basically the getter. Okay, so let's just minimize this piece of code here, and we run this again. Here in Java, you do to convert this book.java into the bytecode, you write Java C. Like we did for Groovy, we did Groovy C. For Java, you do Java C. You do book.java, and you'll notice that this will create another file here, right? It came here as book.class. Okay, this is now the compiled bytecode. Okay, now the interesting thing will happen. So I'll just do one thing here. I'll create another, and this is my Groovy now again. We'll say sample.groovy. Let's open this. Okay, now this is Groovy. Okay, and this one was in Java. Okay, and we had compiled this Java to a bytecode. Okay, so if I can raise my atom, yeah. Okay, here we can do book equals new book maybe we'll write the name of the book. What's the name of the book? Okay. Groovy in Action. Okay. So this is my book, and then we'll say book dot actually print line book dot get name. Okay. Very interesting thing here. This book object was actually created in Java. You have seen this earlier. We compiled it, okay, and now we are actually referring it in this book object in Groovy world. Okay, so where's my CMD? Okay, it's here. Okay, so if I run that sample.groovy, right? You should have printed, man. Just 1 second. Oh, I didn't save it, sorry. If you run this, it will print, okay? So like we had earlier told, like Java and Groovy, they are in tongue and groove fashion. I had created one book object that was actually a part of Java world, not of Groovy, and Groovy didn't know anything about it, okay? But once you compile that, it gets converted into the dot class file like we have here, okay? This dot class, okay? Now for JVM, it doesn't matter whether you created this book class in Java or book class in Groovy. We can create this the same thing, this book.java as book.groovy, and then from Java world, I can create an object, or I can call method on book object within Groovy. So it is very much deeply integrated with each other. Okay. Is it clear?
Hi, Saurabh.
Yeah.
Yeah, Saurabh. So if we want to put that Java class, means whatever we get compiled Java,
yeah,
bytecode,
yeah,
in different folder, then we need to import that, right? We need to write import statement also in Groovy, right?
yeah, that is there. I am just showing a simple example how you can integrate Groovy and Java. Okay, that will
Yeah,
be,
if we put in different folder, means same, not in same place,
yeah.
then we need to do import and all, right?
Yeah, you need to import also, and then you'll have to take care of the class path here as well, because it will ask for whether that which exactly path you are referring to when you're referring to something like book.class. Where is exactly in your drive, something like that.
Okay.
This thing is clear, this Groovy and Java.
Yeah.
Without going into the what exactly this class is doing, or that book dot this one, I don't assume that you actually know this thing, but the thing is, I wanted to show how deeply they are integrated with each other. So if you are very proficient in Java, you can write your entire code in Java and it will run inside Groovy as if it was written in Groovy. Okay, and if you are proficient in Groovy, you can write your every piece of code, every all the application code. Maybe there are 100 of Groovy scripts, okay, and the JVM will have no idea whether it is coming from Groovy. Okay, so it is that that much is integrated with each other. So there's that. Any questions so far?
I have a question here, Saurav. So, is there similar to compiling something like a Java C command and you compile it and then you run Java and then you run it? Similarly, do we have to compile Groovy
Yeah,
code?
so Groovy code is we have two things going on here. This is called a you have to understand that Groovy is also a compile language. Okay, first thing, that one. Another thing, Groovy compiles in two ways. Okay, so when we are doing everything here, like this print line, right? Here one. Okay, when I run this code, no, it is actually compiled. The thing is, the dot class in this case, it actually got compiled and it actually created the dot class file also, but that does not stay on your disk. It was actually in the memory. Okay, when you say something like this, no, something like Groovy C, and then you give something like sample dot Groovy, then the bytecode that is generated is actually on your disk. So when I gave this for hello.groovy, we actually, I think I did it here. Where is exactly? Right. So I did here Groovy C, right? Groovy C hello.groovy. So
Yeah.
it actually got, it created this bytecode hello.class here. Okay. But you don't need to do that. You can simply say Groovy hello.groovy, sorry, not that, sorry, Groovy hello.groovy, and it will print you. It is okay in doing this direct compilation. So, so you may wonder that this thing is there. Let me delete this for you and then run this again. Okay.
So it will do compilation and running it one command itself, it will do both.
Yeah, it will do both. The only difference is the bytecode that is generated in this case when I did this is actually stays in memory. And when you do something like this, you actually get the file.
Okay, got it. That's very clear. Thank you.
Right?
Yeah,
So
thank you, sir. Yes.
if you do this, you actually get your hello.class here. Yeah. All right. So there's that, some basic intro on Groovy. It's almost 6 now. If you have doubts, go ahead. Anyone, any doubt? And by the way, we'll discuss object-oriented in depth. So don't worry if you didn't understand this book class and all those things. Okay, we'll discuss that. Anyone, any question? Any issue regarding running Groovy on your system, or any issue with the code that I ran today?
Saurabh, do you have any agenda, like what are the things that are going to be covered in all 4 days?
Yeah, so I have this. I'll just
Please pause your recording now. Thank you.
Okay. Just a minute. Where is that? Let me stop recording.